This is my partner, Luca, and our project is securing IoT devices. Our customer is Dr. Ruolin, Zhou, and our advisor is Dr. Bao. So a little overview of our project. The goal of our project is basically to be able to implement forward different booting sequences across a SoC board. The board we focused on was the Altera Intel Cyclone 5 SoC board. Yeah, that's the issue. So yeah, and it's basically to implement 4 different booting sequences across the board. These 4 booting sequences were across the QSPI, SD card, FPGA, and then the secure FPGA. And then also, we were to basically measure each of these sequences for time and power consumption and compare them. So for the basic customer requirements, we have 2 general ones. So the first one was to be able to implement 4 of the booting sequences across the board.
So our alternatives are basically using a real-time operating system for with the bare metal application, and also not using the preloader, just to make it simpler and easier to implement. The weakness to not using the preloader is that it will be less secure because there's less stages to authenticate. And yeah, so the next part. So for testing, basically, like I said before, we're analyzing and implementing, and it's just the 4 boot sequences, and then after that we're measuring the power and timing for it. So these are the specific tests that we passed. So on turning on the board, if it's configured properly, it's supposed to just show like the LEDs are supposed to flash, and then also there's booting from the SD card. Basically, for our setup, when we're just expecting it to basically after resetting the board, it will load up it will set up U-boot as the bootloader, and then after the U-boot, after it loads, it will just the SD card boot is simply a simple Linux file system, and then booting from the QSPI, it's pretty similar, only that we wrote the application into the QSPI flash instead. And then there's also booting from the FPGA and then the secure version of that. So for the results, for the very first thing, we tried the QSPI boot, and unfortunately, for whatever reason, the boot process kind of like abruptly stops. We're not sure why. We know that the application is properly placed there because when we wrote the image onto it, it gave us a proper message for it. But we think there might be some issue with our serial with the UART because yeah, the interface just abruptly ends. So that didn't pass. But booting from the SD card, that basically we just expected it to basically as soon as you reset the board to load up U-boot and then load up the Linux system. And then for booting, booting from the FPGA, we decided a slightly simpler approach. just to make sure we could, we simply decided to go make the HBS, load the preloader up, and instead of using U-boot, it simply just loads up a simple application that displays a message. And because of that, the power consumption was slightly less at 0.639 watts, and the overall process was only 8 seconds compared to the 16 seconds that the booting from the SD card took. And then for the technically the booting from the secure FPGA boot, we had issues with converting the SOF file, the SRAM object file, into a way that it could be encrypted. So although we found out ways to secure the board, we weren't able to make an actual encrypted image, so that wasn't able to succeed. So, and then compare our ideal time for each of these tasks and the actual time it took for us was longer. For example, especially with the final presentation, and just preparing for this, like it took around 30 hours instead of 20 hours. And in general, most of the process was just like learning. It was just a huge learning process because we weren't used to Intel and Cortex and the board itself. In previous classes, we used like Xilinx. The major lessons we learned, definitely we could have prioritized more. I would have specifically went for the secure sequence first, since that one was more complicated and more important. We spent too much time working on the QSPI, and we also didn't, because we underestimated the amount of time it would take, we also had issues scheduling. Our familiarity with the board also was an issue. And like I said before, I think the main thing we should have done was prioritize the secure boot. So now, this is the first demo, which is just the booting from the FPGA. It's just it's on a console for the processor. So you can see the console window on the bottom. It's a pretty quick process, like I said, because there's no U-boot or unlike the SD card boot, there's no Linux system or anything. We just wanted to make sure that we could boot from the FPGA, since we spent a lot of time learning how to implement these things. So the SD card boot. The SD card boot is more complicated. It involves using. It has a very simple Linux file system with a simple login as well. It has an incomplete set of commands, and basically, as soon as you turn the board on, if you have the switch on the FPGA configured correctly, it will actually pop up, and I'll show you. This process happens as soon as you turn on the board and turn it back on, or if you press reset. So this is basically the bootloader. It's detecting all the needed files. And probably didn't notice, we just quickly typed in, there was a login and just a basically the password is just root. It's not like a complicated thing. And that was why the SD card boot took a little bit more, like the actual process was, it took more time, and it took more power, like it consumed more watts. And I think the takeaway is that like adding, it's kind of intuitive, adding more stages to the boot process makes like, more power consumption, and it makes the process longer. And that's it. So if you guys have any questions.